Japan lives where the earth doesn't stay still. Earthquakes, tsunamis, volcanoes, typhoons. Because this country sits on top of 4 massive tectonic plates, constantly grinding against each other, experiencing thousands of earthquakes every year, with about 160 earthquakes measuring 5 in magnitude or higher. And yet, its buildings don't collapse, and the reason comes down to 3 systems most countries don't use at this scale. Starting with the first system, which simply makes the building stronger than the earthquake. This is called taishin, reinforced structure. During an earthquake, buildings don't fail because of gravity. They fail because the ground throws them side to side, and sideways forces are brutal. They twist steel, they crack concrete, they tear buildings apart. So Japan strengthens the core using reinforced beams, thicker columns, rigid shear walls, and steel bracing, building a skeleton designed to take the hit and stay standing. This is the standard requirement for most residential buildings. But resisting the earthquake isn't enough, because survival is just the first step. And the next 2 systems go much further. Because even if the building doesn't collapse, it can still be violently shaken. Furniture flies, glass shatters, systems fail. So Japan added something smarter, seismic, vibration control. Think of them like shock absorbers for a building. If you've watched this channel before, you know engineers will put a shock absorber on anything. Inside the damper piston is a fluid that travels between 2 chambers, converting motion into heat. The effects with and without a damper are quite dramatic. Some buildings even use tuned mass dampers, enormous weights inside the building that move in the opposite direction of the sway, counterbalancing the entire structure. So now the building isn't just resisting the earthquake, it's fighting back. But even that wasn't the real breakthrough. The breakthrough was separating the building from the ground entirely. Mention base isolation. Instead of letting the earthquake travel straight into the structure, Japan lifts the entire building onto massive flexible bearings. When the ground moves, the base moves. The building barely does. It's like putting a skyscraper on suspension. In a fixed base building, the entire structure rides the quake. In a base-isolated building, the earthquake impact is reduced significantly. And this third system is the reason Tokyo can survive an 8-magnitude earthquake without shutting down. In many countries, if a building survives, that's considered success. In Japan, survival isn't enough. The building has to keep functioning. Hospitals must operate. Offices must reopen. Cities must keep moving. Because when earthquakes are a fact of life, you don't design just to stay standing. You design to stay alive. But Japan is not the only country located on the Pacific Ring of Fire, which is a horseshoe-shaped area where major tectonic plates meet and collide. On the other side of the Pacific, the United States faces the same threat. California sits directly on the San Andreas Fault. In 1906, a magnitude 7.9 earthquake nearly wiped out San Francisco. More than 3,000 people died. California's building codes are strong and constantly updated to prevent collapse. But in Japan, the goal goes much further. Structures must remain functional, and when building standards fail, the consequences are devastating. In 2023, a 7.8 magnitude earthquake in Turkey led to over 55,000 deaths, largely due to poorly reinforced structures. Many of the collapsed buildings were unreinforced masonry, brittle materials that crack instead of flexing and absorbing seismic energy. Earthquakes don't kill people. Bad buildings do. So if Japan figured this out, why hasn't the rest of the world copied it? The answer comes down to 3 things. First, money. Retrofitting old buildings with base isolation or vibration control can cost millions, sometimes billions. And most building codes are designed to prevent collapse, not guarantee functionality. For many cities, it's cheaper to repair damage after a rare quake than upgrade every structure in advance. Second, frequency. Japan experiences thousands of earthquakes every year, with major ones every few years, like the 1995 Kobe quake, the 2011 Tohoku earthquake, and the 2016 Kumamoto earthquake. In the United States, major earthquakes are far more spread out in time and geographically, and nearly 80% of US seismic activity happens in Alaska. Which brings us to the real difference: density. Tokyo alone has over 37 million people. When you pack that many people into a seismic zone, failure isn't an option. Alaska is the least densely populated state in America, a fraction of Japan's population. Japan doesn't invest in extreme earthquake engineering because it wants to. It does it because it has to. But Japan wasn't always prepared. In 1923, the Great Kanto earthquake hit Japan with a 7.9 magnitude. Fires swallowed entire districts of Tokyo and Yokohama. Over 140,000 people died. That disaster exposed something brutal. Japan wasn't ready. So they changed the rules. 1 year later, Japan rewrote its building code. It became the first country in the world to legally require earthquake-resistant construction. And every following major earthquake forced the code to evolve and added more strict rules to upgrade old buildings that do not follow the up-to-date standards. Today, buildings in Japan are designed to survive lateral forces equal to their own weight, which is something no country has attempted at this scale, which has paid off immensely. In 1995, the Kobe earthquake killed over 6,000 people. But 97% of the collapsed buildings were built before 1981. That earthquake didn't just cause destruction, it triggered one of the greatest building retrofitting and seismic update efforts in modern history. Today, nearly all new buildings in Japan meet strict seismic standards, and most older ones have been upgraded. This demonstrates Japan's successful retrofitting programs when compared to the 1923 Great Kanto earthquake, which killed over 140,000 people. But earthquakes are only half the battle. In 2011, nearly 20,000 people died. A magnitude 9.0 earthquake, one of the strongest ever recorded. Most of the destruction didn't come from structural collapse, as many base-isolated buildings remained operational. It came from the tsunami. Japan sits above a subduction zone, where one tectonic plate dives beneath another, and when the ocean floor moves, it doesn't just shake the ground, it moves the sea. To combat this, Japan has built tsunami walls, early warning systems, automatic bullet train shutdowns, but some forces can't be fully controlled. Japan didn't become the most earthquake-resilient country in the world overnight. It became resilient because the disaster forced it to evolve. When the ground refuses to stay still, you don't gamble on survival, you engineer for it.